The deepest look we have ever had at the Sun comes from NASA's Solar Dynamics Observatory. Because of the development of the latest filter technology, we see the Sun as we've never seen it, with violent upheavals on a ball of fire that provides all of us with life that could also badly damage us in the long term. All our communication networks and power capabilities could be knocked out by an approaching solar storm that researchers are expecting any moment now. We created the SDO systems to safeguard humanity and watch our star a bit more carefully. Our ancestors regarded the Sun as sacred, the Sun being most honored in almost any place throughout the globe as a sun god. The living being, warmth, and center of things was the Sun. This, too, is a symbol of strength and of wealth. We don't worship the Sun as a deity anymore, but everyone knows how important this star is in keeping us alive and warm. The Sun is a wonderful fireball, and incredible things go on there. Although it's a small, light star compared to those in the universe, our Sun is most important to life on Earth. It is a huge cosmic reactor which produces huge amounts of energy by nuclear fusion, which we pick up as light and heat. Core of a star is hydrogen atoms that fuse together to make helium. Solar radiation is the energy that passes through all of the layers of the Sun and into outer space. As you can see, the light that heats you is 150 million kilometers away, and in reality it has taken 8 minutes and 20 seconds to get from the Sun's outer layer to you. But the Sun provides both our source of energy and heat, and is also able to influence the climate and weather on Earth. Today, the Sun has become an important source of clean, renewable energy. The Sun can be dangerous, but solar energy can save us from climate collapse. If our atmosphere goes, our Earth's vegetation will die. Solar activities such as sunspot, solar flare, and solar wind even can completely destroy our entire civilized world in few minutes. Is the Sun about to give notice? NASA is watching our star, and it's with the Solar Dynamics Observatory. It records every tiny ejection and every solar wind. This observatory gives us much more fascinating, in-depth insight into how our star works than we've ever had before. Only because of the color filters can we track the processes live and study the Sun's regions and activities in detail. The Sun images are strong, powerful. What they are is fascinating. What they are is shocking. In reality, even the slightest change on the surface is a gigantic storm and an upheaval in a hot brew of plasma at around 5,500 degrees C. This image from the Solar Dynamics Observatory was captured on December 14, 2023, of a solar flare. The top right of the image shows a bright flare that is shown as such, the extreme ultraviolet filter image, the Sun. At 12, the ejection hit O2, and the Solar Dynamics Observatory chimed in. It had the potential to do great damage to Earth. Solar flares are explosions of energy, 100 times more powerful than any nuclear weapon, that could threaten all radio communications, power grids, and navigation systems on Earth. Normally, the particles are intercepted and dispersed by our magnetic field so that they don't penetrate into the lowest layer of the atmosphere. But when strong storms threaten, our Earth's protection of protecting particles of the Sun collapses, and the particles from the Sun can pass through the protection mechanism. As auroras, we know the wobbling of solar particles in the magnetic field layers. No question, they are beautiful. But if the Sun had even more violent eruptions, the play of colors in the sky could be the play that kills our cell phones, computers, and power grids. The strongest phenomena in the solar system are solar flares which affect the entire solar system. Other names include these storms, which are known as flares classified in classes. The X-class flares are the X-strongest and a powerful source of radiation, rash around the globe. X-class flares have a number attached to them indicating the amount of intensity. More intense X-class flares have higher numbers. X2 flares are twice as intense as X1 flares, But the storm on December 14th had already reached X2 rates. By comparison, M-class flares are harmless and provide many of us the familiar auroras and perhaps the occasional radio blackout. Even more hostile, Class C, B, and A flares are harmless flares that are not really felt here on Earth. Whatever the storm's capabilities on December 14, 2023, it certainly had the means to bring a halt to all of our navigation systems, our aircraft controls, and our radio communications alike. Luckily, these consequences did not occur. How far such a storm reaches into us also depends on how it behaves in space, in what direction its current takes, and if it starts cutting ways. By using the image's peak flux of photons, got in watts per square meter, researchers classify flares. This is a rate measured against the Earth's rotation. Such a classification has been made in order to have a generally standardized scale for assessing intensity of individual solar flares, and to pass on their probable effects on space weather and the Earth with as much speed and fidelity as possible. But it really is incredible, other than in an emergency we have no means of protecting ourselves. And of course, without navigation and radio communications, planes can crash, ships can be lost at sea, and your GPS, one of the most important devices, would only show that it only has one failure. As you're stuck in the middle of the jungle, and we're already depending on it. Then the sun blows a flare, and you might hope your instincts will give you the same kind of guidance as the GPS. In a weird way, the sun tells us something about our vulnerability, about how intimately we rely on technological systems. Now you may say to yourself, "We'll never mind, it won't do, it's never happened before." But this is a misbelief. In 1859, the last major solar storm paralyzed the first newly installed power supply systems and telegraph lines. The radiation from everywhere. There was sparks shooting out the lines. Some telegraph machines started working, even without a power source. For those people were not half as dependent on communication systems as we are today. However, in other places, the Carrington even caused panic. The sky burned on fire. People thought that God had come to wipe them out. When the telegraphs didn't work, it took weeks for the news to reach the people and what it really was about. A solar flare it was, indeed, correctly identified by the British astronomer Richard Carrington as a geomagnetic storm. Value clues are offered by the SDO. The Carrington event scenario tells us to know our star. Since 2012, the Solar Dynamics Observatory, SDO, has been an important partner in our study of the Sun. And since August 2018, that ship, the Parker Solar Probe, has been heading our way to know our star even better. And it's the fastest space observatory humans have ever made, traveling around the Sun many years to make measurements in the hot corona and observe our star up close. SDO will help us to monitor solar activity and better understand how our Sun affects Earth and space weather. We will also need to know everything about the Sun's influence if we are to send people on longer journeys to the Mars or Moon in coming years so that they can expand our space travel. The solar storms can destroy or even kill the spacecraft. Navigation systems. It works with a whole range of sophisticated instruments. High-resolution images of Sun's atmosphere are being captured by the Atmospheric Imaging Assembly, AIA. Helios Seismic and Magnetic Imager, HMI, studies the Sun's magnetic field and dynamic movements in the Sun. The Extreme Ultraviolet Variability Experiment, EVE, measures UV radiation on the Sun. By observing the Sun continuously around the clock through several light filters, SDO never fails to see an eruption, flare, coronal mass ejection. SDO captures even the finest solar magnetic field changes, and due to SDO, we now understand the Sun's complex dynamic magnetic field much better. What does ultraviolet radiation show? Have you ever tried to watch the Sun? In a moment, we humans can't see directly on the Sun without causing a huge damage to our eyes. We have to look away quickly, blink, or be blinded, most of us. It is. Therefore, quite a feat to observe this blindingly hot and bright ball of fire. For example, we could only see the glaringly bright light of the sun, but did you know that the sun produces light in waves which are invisible to us? And if you've ever purchased a pair of sunglasses with a UV filter, you did, because you are looking at one of these invisible wavelengths, or, in certain cases, one of these lights. Blue and green wavelengths of sunlight can pass through our atmosphere and burn our skin. The result is sunburn. Considering the Earth's atmosphere, other wavelengths of light of the sun can't reach into the atmosphere, nor they can through the atmosphere, but they still affect the upper part of the atmosphere or just pass by us. As a result, sunlight and solar radiation are much more important, much more than just the bright yellow or white rays of sunlight that the human eye finds so desirable in spring. The solar emission spectrum is far richer, and so is the influence of solar activity on our planet and on our organisms. 4 telescopes on board the SDO image the sun in the UV spectrum. The ultraviolet rays hit the telescope. A mirror with special coating filters the light to make the images available in different variations that appear yellow, greenish, or blue to us. Basically, the telescope does nothing more than your cell phone does when you use the camera. The incoming photons are recorded as pixels, converted to electrical signals, and printed. The sun also radiates radio radiation like radio waves, ultraviolet radiation, and infrared radiation as well as visible light. Because the sun's activity can also be seen with large radio telescopes like the Solar and Heliospheric Observatory and the Solar Terrestrial Relations Observatory in Goddard, it's possible to see the sun's activity. Extreme ultraviolet radiation is the light that can give us trouble on Earth. These very active and very energetic photons actually trigger chains of events on Earth which we still don't fully understand. Most of the solar radiation is absorbed into the atmosphere of our planet, and we should count with solar storms and consequently attacks with extreme ultraviolet light increasing. To predict possible events, researchers are using computer models to try to predict events and to develop protection systems. Scientists around the world are now looking for ways to make our electricity and communication networks less vulnerable to the sun's rays. Flares of Class X1 or higher are warned of by early warning systems such as NOAA's Space Weather Prediction Center in Boulder and others to warn energy companies and airlines. Flights will be canceled and electricity customers will be warned as soon as the first disruptions are detected. If you want to see many more videos like this one, now is the time to subscribe.